So, hello and welcome you all to today's LeetCode challenge. This is our day 2922, and today's question is question number 2493. Divide nodes into the maximum number of groups. We have given an integer and represented the number of nodes in an undirected graph. The nodes are labeled from 1 to n. We have also given a 2D integer array edges where edges of I is equals to a of I comma b of I. That indicates that there is a bidirectional edge between a of I and b of I. Notice that the given graph can be disconnected as well. That given graph has many components. Divide the nodes of the graph into m groups, one based index such that each node in the graph belongs to exactly one group, and for every pair of nodes in the graph that are connected by the edge ai comma bi, if ai belongs to the group with index x and bi belongs to the group with index y, then the absolute difference between y comma x is equals to 1. So we have to return the maximum number of groups into which we can divide the nodes, or if it is not possible to divide nodes into such groups, then we have to return -1. Let us take an example. The example number 1, for input n equals to 6, the edges are given for us that 1 comma 2, that means there is an edge between 1 comma 2, 1 comma 4, 2 comma 6, 1 comma 5, 2 comma 3, and 4 comma 6. So we have to divide these into such groups that the absolute difference between the each group that has an edge is equals to -1. The given constraints are that one is always n is always greater than equals to 1 and less than equals to 500, and edge length is equals to and less than 10 to the power 4. So we have to write a write a solution that is better than n square to tackle the TLE. The topics related to this question is BFS union, find the DSU part, and a graph. So by the observation we can observe that if this given graph is not a bipartite graph, then we definitely cannot we definitely cannot make any groups, so we have to return -1. So we always have to check if the given graph is a bipartite graph. First let us code this, and then we will try to debug our solution. Let us first make the adjacency list. From the edges, we have to maintain an adjacency list. Then globally initialize a column variable and a 2D array of array. Then a flag that keeps track if that graph is a bipartite graph or not. Now initialize our helper vector, that is res. Define the DFS function, that is basically do the DFS part for us if required for us. adjacency of u. If not goal of v, then we have to recursively call our dfs function for v and 3 minus c, that means 3 steps behind. Else if call of v is equals to c, then we have to make our flag as false. That means graph is not bipartite, and if is not bipartite, then the given graph is cannot be grouped together. This function basically check if the given graph is a bipartite or not. Now we have to calculate minimum distance between all nodes, and that could we have done through the simple BFS technique. We can run our for loop from I equals to 1 till 500 and make our 2D DIS as int maximum, that is initialize that with int maximum values, and then we have to maintain a QE of int named Q, and we have to push src in that. Then we have to move on QE until Q dot empty pop out its first element, remove that first element from QE, and in adjacency list uh, traverse all the adjacent nodes to this top in using this adjacency list, and check if the distance for src of v is greater than this of top plus 1. If this is the condition, then we have to update our new distance plus 1. That means this step is basically like uh, like this grass algorithm where we have to find the shortest path. So this is finding this step basically finding the shortest path for to a given node. Now in our magnificent sets, we have to first run a loop and make our column array to initialize with 0 like this, and then traverse on the 2D vector edges to make our adjacency list. U equals to edge of 0 and V equals to edge of 1. Now we know that there is a edge from U to V. That means push back U to V, and then that this is a bidirectional, so we have to keep track of a edge from V to U as well, like this. The adjacency list is now created. Now for int I equals to 1 till I equals to n plus plus, do a BFS for every I and initialize our answer, and in degree for every node. Traverse on this and check if column of I equals to 0. Then we have to clear our resultant vector, or our resultant helper vector. Make our flag as true and then a DFS for every I, and check if not flag. That means this is a bipartite graph, so we have to, this is not a bipartite graph, so we have to return a -1. And if it is a bipartite graph, then we have to find the maximum distance for every node possible using res. So res basically stores the maximum distance for every node. Like this. And we have to add our max test into our answer, and we have to finally return our answer. Let us run this. We have forgotten to add a semicolon. Let us run this and check if it is. It is getting a runtime error because of the integer overflow in QE, and we have forget to add. This is still giving me the TLE error. What? Yeah, I figure out that I forgot to add This of src comma src equals to 1. I forgot to update this src of src to 1, and now this will run fine. I think this will run fine. Yeah. So if we submit this, then yeah, it got accepted. So now let us quickly go through our code once and try to debug our code, what we have written in that. So let us took our example number 1 as our reference. We have given n equals to 6, so the graph should be like this. Let us make a graph here. This is 5, 1, 2 and 6. There is a node here as well. So and two nodes here. There is a edge between this, like 5 to 1 and 1 to 2. There is a edge. So 1 to 2. There is a edge between 1 to 4. So let us add this as edge 1 to 4. There is a edge between 2 to 6. So let us add this to this. Then there is a edge between 2 to 3. So let us edge like this. And then there is a edge between 4 to 6 as well, like this. Let us name these nodes. So what these nodes are: 5 1, this is 5, this is 1, this is 2 4, this is 2, this is 4, this is 3, and this is 6. The given input is like this. Let us copy this from here, and the given input is like this. There is an edge between 1 comma 2 and 1 comma 4, 1 comma 5, 2 comma 6, 2 comma 3 and 4 comma 6. So the adjacency list will look like for 1 we can move to 5, 2 and 4, 5, 2 and 4. Similarly for 2 we can go to 3, 1 and 3, 1 and 6. Like this. For 3 we can go to 2 only. For 4 we can go to 1 and 6, like this. For 5 we can go to 1 only. There is a direct edge between 5 to 1 only, and from 6 we can go to 2 and 4. So this will our adjacency list. Let us try run our code first. For int I equals to 1, I less than equals to n. Let us first clear adjacency. That means the array of vectors we declared is first cleared. That means this is empty, and using this mem set we are initializing our call to zeros. That means this is initially 0 all, 0 till last index, and then we are making our adjacency, creating our adjacency list. So here we created our adjacency list. The adjacency list will look like this. So for I equals to 1 till I less than equals to n, do a BFS for I. Here n is 6. So for I equals to 1, let us see what happens if we do the BFS. So we go inside the BFS function. Here for I equals to 1, I less than equals to 50, DSC of SRC of I is initialized with int max. That means this SRC will first receive 1 as the argument. So this is 1 comma 1 to 500 will initialize with. That means these are initialized with int max. That means these are first with infinity, like plus infinity. Suppose dot dot like this till the index 499. I mean index 500, because I is equals to 500. So this will goes to index 500, 1 comma 500, like this. And then this initializes the DSC of SRC to 1. That means 1 comma 1 is initialized to 1. So this will changes to 1. This is 1 now. Initialize an QE. So here we initialize our QE and push our SRC into QE. That means we pushed 1 into this QE. QE front is pointing to, let us take another color for the front part of QE. This is QE front. Let us name this front pointer, that is pointing to 1 now. Front. So while Q is not empty, we will check if Q is empty. No, it is not empty. So we will take the front part of Q into top. That means there is a variable initialized named top, and that will take the 1 as one as a variable initialize, and we pop out our first element of queue. That means this this will pop out now from queue. And for int of v of in adjacency of top, that means we have to go in adjacency of 1. What are the elements of 1? If we go in adjacency of 1, we will find that we can go to 5, 2 and 4. So first we go to 5. That means this we received 5 as an argument first, and this will check if DIS SRC of V, that means DIS of 1 of 5 is greater than DIS of 1 of, and top is 1 plus 1. Let us check if this condition is true or not. DIS of 1 of 5 is infinity. Here we can see that that is infinity or int max. DIS of 1 is 1, and if we add 1 to it, then this is 2. So this is all this is basically greater than this. So if condition gets true, and DIS of 1 comma 5 is updated to 2, so this condition get redundant to like this. So now we have to update our DIS of 1 comma 5 to 2, and we have to push V inside the queue. That means uh, V, that is holding the value 5, is pushed inside the queue, and the previous front that is pointing to 1 is now pointing to this 5. Now again the for loop will take the adjacency of next element, that is 5 is over now, and we will now take the value 2 like this, and again check that if dis of 1 of 2 is greater than equals to dis of 1 of top is still the previous, that means that is 1 plus 1. Yes, this condition is true. That is 1 comma 2 of dis is holding a infinity or int max. So this 1 comma 2 is now updated to value 2. So now erase this and put here the value 2 like this, and push this 2 inside the queue. That means here 2 gets inside the queue, and now this we will pointing towards the next element of adjacency. So this will point to 4 now. Again, the condition gets checked if DS SRC, that means this is 1 and V is 4 now. V of 4 is greater than equals to DIS of 1 of top is still holding the value top is still holding the value 1. This if this condition gets true, DIS of 1 comma 4, yes, this is infinity here. Basically this is infinity, so we have to uh, reassign the value 2 to this, like this. So this gets 2, and now this for inner for loop is over. So this goes to this while loop and check if q is empty or not. So we check if q is empty. No, it is not. The q is still containing two elements. The q is first front part is now pointing to this 5. So top will now contain the value 5. That means this value 1 is now discarded and top will contain the value 5, and this 5 is pop out from the QE, and this front will now point to this. Two. Now top contains 5. Again, for every element of adjacency of 5, this for loop will go. So for every 5, uh, 5 can go to only 1. So this we will receive only 1. This previous v got discarded, and this v will now received 1 as the input argument, and this will check if dis of 1, that is src, is still 1, and this v is now 1, and top this time is now holding the value 5. So this will check if dis of 1 of 5 plus 1 is greater than. So this will check that dis of 1 of 1, dis of 1 of 1 is here. It contains the value 2. Let us rewrite this clearly. This is holding a value 2 now. This 2 is greater than 1 comma 5. 1 comma 5 is 2 plus 1, that means this gets 3. Let this will check, then 2 is greater than equals to 3, that is a false condition, so this loop does not get executed, and this will again check if q is empty or not. So this q is still not empty, it contains 2 as uh, and 5 gets removed, but q is still not empty, so this time top will receive the value 2. So now top is 2, and this 2 is pop out from QE. Now go to the elements for adjacency of 2. So let us check for 2 where we can go using adjacency list. For 2 we can go to 316, and one by one we will receive 3 as input first. That is, V is pointing to 3 this time. Let us check if DIS of 1 of 3 is greater than equals to DIS of 1 of top is this time. Top is 2. If this condition gets true or not, DIS of 1 of 3 is what? DIS of 1 of 3 is infinity here. So basically infinity is clearly greater than equals to this 2 plus 1. So this condition gets true. So this DIS of 1 of 2, that means this 1 of 2, 1 of 3 is updated to this value, this previous value. That means this DIS of 1 of 2, this is updated to 3 like this. This will get updated to 3 this time, and that V, that is 3, is inserted into QE. So QE is now this, and suddenly this front part is now this, like this. Inner loop is over for this 3, so this V will get discarded, and now again points to this 1, like this V. Now this will again check if DIS of 1 of V, this is, that is 1, is greater than equals to greater than DIS of SRC, that is 1 of top is still, top is holding the value 2. So DIS of 1 of 2, let us check if what is DIS of 1 of 1. DIS of 1 of 1 is 2. So the condition gets 2 is greater than 1 of 2. 1 of 2 is 2. 2 plus 1. So 2 is not greater than 3. So condition, if condition get false, and the next V is updated, that means this V is discarded, and V will now points to this 6. Again the condition gets checked, DIS of 1 of 6, this is greater than DIS of 1 of 2 plus 1. 1 of 6 is 1 of 6 is infinity, and 1 of 2 is 2 plus 1. That means this infinity is always greater than 2 plus 1. So we have to update our DIS of 1 of 6 to this 3. So update our DIS of 1 of 6 to 3, like this. And we have to push this V inside QE. So push our v, that is 6, inside the QE. There are no adjacency elements for this v, so this v will get discarded. This v get discarded, and this inner loop is now over. This will again goes to this while loop and check if this queue is empty or not. No, this queue is still not empty. This contains 3 and 6, but this time the front part is pointing to 3. So we have to pop out this, and now our top is containing 3, and this 3 gets pop out, and suddenly our front is now pointing to this 6. Top is now 3, src is still 1, so this will go to adjacency of 3. Let us check what adjacency of 3 says to us. Adjacency of 3 is here. We can only go to 2, so we will receive the value 2. So inner if loop check that if one of 2 is greater than one of top is now 3 plus 1. That means 1 of 2 is dis of 1 of 2 is 2. That means 2 is greater than 1 of 3 is 3 plus 1. So this condition is false, and this if loop does not execute. So again we have to go to our QE and check whether is empty or not. No, this is still not empty. So we have to pop out our front part, and our top will now contain 6, and this node is pop outed from QE. Our top is 6 now. For 6 we have to move on its element in adjacency. From 6 we can move to 2 and 4 only. So we will receive a value 2 first. That means this we will point to this 2 first. Now we have to check if dis of 1 of 2 is greater than dis of 1 of top is now 6. So 1 of 6 plus 1. What is dis of 1 of 2? Dis of 1 of 2 is 2. So 2 is greater than 1 of 6 is 3. 3 plus 1, and that this condition is false, and if this is false, so this if loop does not execute, and this checks if q is empty or not. So this time we found out that q is empty. So this bfs function would return, and this q is now deleted from the system, because this is initialized or used in a function, and if this function is goes out of the scope, the memory for all the variables or data structure allocated in this that gets deallocated as well. Now this BFS function is over, and then this will start answer of 0 or in of 0 is now initialized, and we have to move on our I equals to 1 to I equals to n, that is from I equals to 1 till I equals to 6. We have to move for this first example and check if call of I equals to 0. That means for I equals to 1, if call of I is equals to 0, yes, call of I is equals to 0 if I is 1. This is true, so we have to clear our res variable. Res variable is already cleared till now because we do not do anything with res variable till now, and the flag gets true. So flag that is some flag variable that now points to true. This flag is true now, that means 1, and in is incremented by 1, so let us increment in by 1, that means this in is 1. Previously it was 0, and we have to do a DFS for I is 1, still it is 1, so we have to take care where is I is still pointing. I is 1, here 1. DFS function will called for 1. What is DFS function will do? DFS this U and C is initialized to 1. That means this is a default parameter. This U will receive 1, and this will check if a call of 1 equals to 1. That means call of 1, this is 0, this is not equals to 1. So oh, calls of my mistake, this will make call of 1 SC. That means a call of 1, this is changed to 1. So this call of 1 is now 1, and res is now pushed back to U. That means let us make our res. Let us make our res here. This is our res. Let us name this. This is res. This is res. So this res will contain U, that is 1. So let us push 1 into this res. For auto V and adjacency of U, that is for adjacency of 1. What is adjacency of 1? 1 adjacency is 5, 2 or 4. That is, first we will points to this 5. Let us clear our previous operations. But we now this is fine now. So our DFS of V will now points to this 5. V contains 5 and this check if not call of 5, that is call of 5 is contain a 0 or not. This contains a 0, so call of 5 is a 0 and not for 0 is true. So this is a true condition, and DFS is still called for 5 and 3 minus C. That means this time U will receive the 5. U is 5 now, and this C will receive 3 minus C, that is 3 minus 1, that is 2, and C is 2 now. 2. Now call of U is C, that means call of 5 is 2. So update our call of 5 is 2 here. We have to push back our U in res. U is 5, so we have to push back our 5 here. For every element of 5, for every element of 5, elements of 5 are this 1. So we will now points to this a DFS call. Let us check if not of call of V, that means not of call of 1. Call of 1 is 1, that means call of V is 1, and not of 1 is 0. So this if gets false this time, and this if get false, so this else if gets checked. If call of V is equals to C, that means call of 1 is equals to C. C is 2 and call of 1 is 1, so this condition gets also false. So the DFS call for this DFS call for this 5 is now returned to this previous call, and at this call V is pointing to 5 and C is 1. Now again uh, uh, the other elements of this 1 is checked, this 5 is checked, then again 2 is checked, and then 4 is checked, and then this DFS function will push back the every possible combinations together, like 1 together, 5 together, and 2 and 4 together. This will make our in function as like that they are together, and 3 comma 6 as together, like this. So our this makes this function will contain the answer, and this answer is updated as per our max disk. So this is all from my side. The video gets a little bit longer this time, but I tried to explain as best as I can. And thank you so much, guys, for this today's lead code session. If you like and if you do understand something, then please like and subscribe to my channel, and please keep support. Thank you.